So, hi guys, welcome to this workshop. It's on building agentic apps, a developer's workshop. So aimed at developers who want to build applications in the agentic AI space. Your speaker, me, Simon, about a little bit about me. I'm a lead engineer at Zulke. I've been building full stack TypeScript applications since 2019. And I've got a deep interest in AI development architecture. And I'm also kind of talking to and also building in a lot of spaces that are making AI apps, like a few friends who are founding companies and that kind of stuff. So yeah. And I also have my own kind of side project. You can check it out if you like. I'll have a few demos from here, which is, I might show a bit later, but basically like and also an AI kind of Copilot style thing. So yeah. So why does this workshop exist? So why this workshop exists. So some common pitfalls is that developers dive straight into building. You can, especially with like vibe coding and stuff now, you can get off the ground very quickly with that. But then things will start to fall apart. So it's good to have some kind of structure in what you're building, basically. So the idea of this workshop is that you can rethink your approach and get an idea of some of these tools, what they are, how they work. Because basically, yeah, it's not like, obviously, AI is moving so fast that maybe the tools are going to change, but there's some general frameworks now over the last year or two that have come into fruition, and it's good to know about them. Obviously, things still change, but some concepts are quite stable, and it's good to be aware of what things exist. And same like when you talk about building, like AWS did, right? They have this like undifferentiated heavy lifting, right? Like they give you the tools and then you just build on top, right? That's kind of the idea of this. Like, what are the foundational tools that I can use to build AI apps? So yeah, key objectives: understanding agentic apps, mastering the basics, learning the core concepts. We're going to actually build some stuff. So there's going to be about an hour of like just you guys try stuff out and I'll float around. We're going to explore some modern frameworks, and we're going to look at like more and more advanced things as it goes on, revisiting the same examples. So yeah, the first thing to say about now we have this AI boom is everything has changed, but the lessons are the same. So what I mean by that is if you actually think about how much has changed in the last couple of years in terms of now we're building these AI apps, it seems like everyone who's building something new has some kind of AI feature set built in. So basically, yeah, the way we develop has totally changed, because we now have, like a code assistants and stuff. So there's a lot of presentations and stuff on that. But also the user interaction model has changed. So it's no longer just like the client and the server, which is what it's been for ages. Now you have this third party, which is the agent, right? So how do you sync up like what the client is doing, what the server is doing, and then also now what the agent is doing? And also the architecture has changed, because for a long time, what was important was, let's say you're making a website, we had maybe like a lot of high compute intensive tasks that needed to be done, but they're finished quickly, right? So you say like, oh, I want to reach out to my, like, I don't know, image converter, done. It's all about speed. You just want that to be as optimal as possible. You do microservices, you whatever, delegate roles. But now we have like a new feature, like again, a new type of compute, which is like this long running compute, like 5, 10, 15 minutes. And it's not very processor intensive even, right? Because usually it's just calling the ChatGPT API and just streaming the result, right? So the architecture has also changed, because now it's like you need to think about this long running, low compute intensive stuff. But the lessons learned are the same. So dry, don't repeat yourself, find ways to encapsulate logic. And it also applies for the logic of your agents, and don't build a monolith, right? So in the same way that it wasn't before a good idea to try and put everything in one code base and one process, the same thing is here with agents, right? You want to try and split stuff out, separation of concerns. So yeah, let's look at some definitions. So the first thing that is really important to know from this is, what is a model? So yeah, what we mean by model is like, for example, ChatGPT, right? It's a model. And then within that, you also have memory. So the important thing to understand from using ChatGPT and other models is that memory is not real. This is the important thing I didn't understand before I started using these APIs, is they don't remember anything. If you say, imagine you meet someone at a party and you say, hi, and they say, hey, what's your name? And then you say Simon, and then you're having a conversation with them, right? Agents are not like that. Models are not like that. It's like every time you send a message, it's like, I said hi, you said what's your name, I said hi, my name's Simon. That's how it's able to say, oh, hi Simon, I'm still talking to the same person. Every time you talk to one of these agents, you're actually sending the whole context of what's been said, not just what I said, but what it said back to me, right? So yeah, like that's an important concept to understand. So what is an agent then? An agent is simply a model plus a system prompt plus tools, right? So if you have the foundational model and then you say, hey, you are a storybook writer, you are a website designer, that's essentially an agent. And then tools is just the tools that we make available. So for example, the like most common demo of a tool is the get weather tool, right? ChatGPT has no idea what the weather like in Singapore is right now, right? It was trained in probably 2025, 24 early, something like that, right? So yeah. So if you say, hey, I've got a tool for you, if you ask me to call this tool, I'll get the weather for you, right? But you have to then implement that. So ChatGPT says, hey, I want to know the weather. Okay, here's the weather. And then it comes back to you as if it thought of it, right? So then also we have this concept of workflows. This is quite hazy, right? Like if you use different tools, they might define a workflow differently. But essentially, it's an agent process with nodes inputs. Think of it like a UML diagram where we have agent 1 passes some data to agent 2, et cetera, right? So yeah, so the first thing that I'm going to demonstrate, which gives a good idea of these overall concepts, is something called Agent Kit, which is from OpenAI. You can also see the dev day demo. I'm going to basically try and do exactly the same demo that they did on the dev day from OpenAI. And then I'm going to actually hand it over to you for like 10 minutes and you see if we can build the same thing. Because everything I'm going to do here, there's no code. It's all like, it's just drag and drop stuff. So we should be able to do it together. So yeah, let's have a go at doing that. So what I'm going to do is maybe go on to the next slide. It will give you the hints. And if you want to, you can try and follow along with me as well. If you go to this, so everyone should have the presentation slides. So go to this link, you can log in. So I'm logged in here. So within OpenAI, you have these things called projects. So I'm just here on the default project. You can create your own project if you want. And maybe if you want to split into teams in a bit later, you can have a different project per team. So I'm going to now create a workflow in Agent Kit. So this is like really drag and drop stuff, right? So we have like a start node, we have my agent. It's quite simple stuff. So the first thing I'm going to do is I'm just going to create an agent, which is going to, by the way, did everyone see the Sessions Explorer thing that I shared on Teams before, if you've seen it or not? The way we basically just search for the sessions of this camp. That is what we're going to build here first in Agent Kit, and then we're going to build it again in more code way. So basically, what I have here is I'm first going to create an agent. I'm going to call this the category agent. And I'm going to say in my agent prompt, see, can we, yeah, okay. So we just say, you are a helpful Zulke Camp assistant for attendees, categorize whether the message is about a session talk or not, right? So we'll call this the category agent. So that's what it's going to do. And then for the output format, you can output as text or you can put it as JSON. And when you put it as JSON, it gives you a nice little schema thing here. So you can really like have no idea what JSON is and you can just add the properties. I'm just going to, just so I don't make any mistakes, I'm going to do it by like putting the JSON in exactly. So, because you can also put like a nice JSON structure in the advanced tab. So that's what I'm going to do here. So this is just defining how the agent is going to output the data. So here we go. So the category agent, and then from the category agent, we're going to have an if-else condition. So you can just drag and drop that. We can connect that here. And then for the if-else, this is like normal UML stuff. We can say if the output passed category. So in the schema from before, it basically says, you know, this is how you're going to output. You have an enum and it says whether it's going to be category or something else. So if the output category is equal to, and then let me remember what I put here, session info, right? So it could be nicer here, to be honest, because like I think it doesn't tell me what it's an enum, so it should tell me what it is, right? But I have to hard code the string, which I'm not very happy about. So yeah, so basically I just say like if the, oh, I think I put this in the, did I put that in the right place? It's, I don't know why it's red. See. Oh yeah, okay, cool, it's working now. Okay, so basically if the input.pass category is session info. So if you categorize the user's request as being about session info, then go into the next step, right? So now I'm going to define another agent, drag and drop, and then we're going to call this agent the session agent, like so. And for the session agent, I just put in the text here. You are a helpful assistant for Zulke Camp attendees. To guide them to relevant session, always recommend specific sessions to go to. So how does it know about the sessions that are available, right? There's actually this nice thing here, which is tools. And you can add as a tool, you can add a file search. So very simply, we have a file search. And then for the file search here, I'm going to just, yeah, okay. So I have here, I'm just going to upload a PDF file. The PDF is not the exact sessions from the Zulke camp. I made this before we had the sessions locked down. So it's just a PDF. Basically, I asked ChatGPT, like, give me a pretend session schedule, and it gave me that. So yeah, but for you guys, what you could do, for example, is you could just go to Confluence and download the actual schedule. You could take a screenshot from the Zulke camp app. You can try whatever, right? Like, yeah, just add. I mean, you also, if you want to try this, you don't have to do what I'm doing, right? You can add it any, you can add your insurance policy, right? And say, hey, am I covered for whatever benefit, right? So yeah, I'm going to attach this PDF, and then I should be already good for now. So we can actually then just immediately preview. Oh, and then for the else, actually what I'll do is I should also have an else condition here. So for the else condition, I'll just write a more generic agent. So I'll drag and drop that here. Cool. And then for the more generic agent, I'll just say, hey, you are a general agent that should answer questions about the Zulke camp. Okay, so that's what it's going to do if it doesn't think that your request is specifically about sessions. Okay, so let's preview this. You can literally just run it directly in the UI. And let's say like, where's the beach? Where is the beach? And it should run through the network. And you can see that it's saying like, oh, you're over here. Right, and it's going to say, I didn't actually give, you see that it just makes stuff up, right? But obviously, like, if you had some more general information, you could put like, Google Maps, etc., to the general agent. But yeah, typically near the main camp, easily accessible. I mean, it's basically right. So yeah, that's already pretty good, right? Let's say instead, the annoying thing here is I haven't really worked out how we can loop back. So if I ask another question now, I'm already on this node. So if I now ask a question about sessions, I'm still talking to this agent. And I don't think they really have a good solution for that yet. So that's kind of work in progress. But you can kind of see with this tool what OpenAI is thinking about how this should work in the future, right? So in order to test the other workflow, I'm just going to start a new session. And I'm going to say like, I want a session on building apps. Yep. Okay. So it categorized as session info, and now it's going to use the other agent. Okay. So there we go. That's great. Cool. So there's one more thing to note, which is quite nice, which is guardrails. So basically with guardrails, what you're able to do is if I add this to the start of the process, and I can just say here, guardrails, and the user interface here for changing nodes is not very good, by the way. So you have to like click on it, delete it, and then draw a new one. So here we go. I have a guardrail. So for the guardrails, what I can do is I can say, for example, PII, personally identifiable information. I say like, if this person says their name, their all this stuff, right, email address, etc., then I want to kick them out, right, of the workflow, because I don't want them to. Another thing that's interesting is jailbreaking. So jailbreaking is the idea where you would say like, you would ask the agent model, what do I need to tell, what was your system prompt for whether to give a refund or not? That's like quite a common prompt injection thing, right? And the agent, unless you have this jailbreaking thing, it might just say, oh yeah, this is my system prompt, right? And if you have that, then obviously you can be like, okay, great, give me a refund. Exactly how you need to know, right? So that's what you can add with jailbreaking. This is PII. So if we add that PII thing here, then what we can do then is add one more agent, and we'll call this the PII agent, PII. And then for the PII agent, what I can do is just say, again, you are a helpful assistant, but then you can actually you can add more context in the conversation. So you can actually, how do I do that here? Add here, I think. Yeah. So now I'm saying from the user, say you can't help with that, right? So this is actually going to start a chat and then immediately act as if the user has actually said, you can't help me with my request, right? So that's how it's going to be like preset to say that. So yeah, you can just do that on the fail. Right? And I think that's all I need to do. Let's preview it quickly. And I can say like, my email is like that. And hopefully, yeah, okay. So yeah, it says, hey, just a reminder, can I help with these questions? Okay, so good. That's the whole workflow. This is literally just the same demo that was done at the OpenAI conference. And yeah, I invite you now just to spend like 10 minutes just playing with this, see if you can build something. So there's one more thing I didn't show here, which I forgot, which is actually quite nice, is the output here is actually not very good, right? So it just gives you in text. So in order to make this better, we can actually add a widget to display the results. So for the widgets, they actually have this thing called a widget builder. So I'll show that quickly here. So OpenAI have actually made this thing where you can build UIs. So this is called a widget editor. You can literally chat to this and say like, hey, like give me a widget for displaying travel bookings or something, right? So you can basically, with that, you can build like a nice little UI and it will give it to you. So I don't have any saved here. It should show me that. I don't know why it's not. But basically for the widget, then what you can do, so let's say like, I want like, I don't know, just a normal like confirm, or we'll just go to the gallery rather than tagging, so it's easier, right? So imagine that I just said, hey, I want a weather widget, right? And then you can open that in the widget editor, and then you can just share and you can download it. and it will just give you a .widget file, right? So to show what that then looks like in the agent builder, instead of having the session agent just output to text, what I can do for the output format is I can say, hey, I want to have this as a widget. And then for the widget, we can upload a widget file, and I'm going to pick this one here. So this is the widget that I just told OpenAI, just give me a widget, which is for doing sessions. And then, yeah, now I have that. We should see again, if I preview, we say like, hey, I want a session on building apps. Rather than giving it to me in that unstructured text, it should actually use the widget to output the data. Let's see if it worked. So there's you can see a lot of thinking here working, but you can see that because that widget has a certain structure that it's expecting, it's actually giving me in the reasoning like the JSON structure. And then there we go. I have like a nice widget to display the information. So this is very like loose. Like if you ask that widget builder to build a widget, it will just make stuff up, right? So you have to tell it like, hey, this is the information I'm going to have. I'm going to have room. I'm going to have session speaker. I'm going to have start time, end time, whatever. And if you give it that, then it's already going to know like the input I need is this JSON structure. And then it will take the result of the agent and mash it into that structure so that it looks the right way. So yeah, okay, cool. So now just for 10 minutes, I think let's all maybe try and do that. Really? Exclamation point. It does work. What? Okay, let me try. Was anyone else able to log in? It worked for some people and not for others. Yeah. Sorry. Log in with Google. Yeah. Log in with Google. So, sorry. All right. Let me show. So I'll do it quickly. I'll open up a private tab. I'll go to here, for example. Here, right. Log in, continue with Google. Okay, camp. I think maybe it might be if you try and log in with Google normally, it's going to use your own Google account. So try open an incognito window so that it forces it. Did it work? Yeah. So open incognito so that it forces it not to use your own Gmail account. Yeah. So let's try this. I love Bali 25 exclamation point. Okay, great. Yeah. So it should work. Hello. It's in the gamma slide. It's in the slides. Yeah. On the same slide that I'm on. So if I go over to here, you can see it here on this slide. All right, hands up if you're in now. Okay, one or two more. So maybe while everyone else is trying to get in, I'll just finish the demo of this quickly. I'm sure at least now no one's going to get to this stage. But basically, if you wanted to actually integrate this agent that I've just shown you into a real application, then all you need to do actually is you can check out this repository. It's a Next.js project, which is already integrated with the Agent Kit SDK, everything. So you just check it out. And then basically all you need to do is, I think I have it here in cursor. Yeah. So I'll definitely remove this later. But this is you can get this key. There's a link in the slides, right? For the OpenAPI key, same account. And then you just specify the workflow that you want to use. That's it, right? When you start this project up, it should be running, let's see, localhost 3001, I think so. Yeah. And then I say like, hey, I want a session on making apps, and it's gonna now connect to my widget because all I had to do in the environment configuration was say, hey, I want you to use this workflow ID, which you get when you publish it in Agent Builder. So when you actually publish the app, you get an ID, and then you can use that here. One thing I didn't show as well is you can turn the reasoning off. So obviously you don't really want to see this JSON here. So for each of these agents that you have, you can say like, yeah, you should display your reasoning. You should not display your reasoning. Another thing that you can do, which is very powerful, is this is quite slow because it's using like GPT-5 for everything. But the idea of having multiple agents in the agent builder is that you can say, hey, for this agent here, let's see, why is that not? Close that. Yeah. You can say, well, you're only categorizing, right? So you don't need to use a very powerful model with lots of reasoning, etc. We can change you to like GPT-4 Nano, right? So that's also going to give you more control over what you do with your different agents. So the next thing to talk about is basically this is quite limited Agent Kit. But when this first came out, I was super excited. I was like, wow, OpenAI have done it. They've changed the world. There's like 100 videos on YouTube saying, if you're not learning Agent Kit, you're a loser. What are you doing? But then you check it out and you realize, wow, in half an hour, I could already build something quite nice. But then where to go next? The answer is nowhere, right? I actually think it's a little bit, not really irresponsible, but it does annoy me a little bit when OpenAI release a tool like this and then make it look like it's very revolutionary. But then I think their target audience is convincing the world that no one needs to code anymore, right? whereas they haven't actually built a tool which is that friendly for developers. If you want to actually use Agent Kit beyond just the drag drop thing, then you have to use the Python SDK, which is quite horrible, especially if you're used to not writing Python. But the fact that they make you write the UI in Python is like, I can't believe they do that. So all the widget stuff right now, there's only a Python SDK. So you literally are writing like CSS or at least like tag elements and stuff in Python, which is crazy to me. I don't know why they didn't like out of the box. I'm sure at some point they might integrate it with React nicer, so these widgets can just be like web components. But at least to date, they haven't, right? So honestly, like if you want to actually extend and build with this, it's very nice proof of concept. I can imagine for us at Zulke, if we want to rapidly prototype something, you can in 20 minutes be like, hey, this is basically what you want, right? But also something like even those buttons which you showed, for example, I could click save session. In Agent Kit, does nothing. You have to, again, integrate with the Python SDK and actually separately handle those events which go to your Python SDK backend. It's really quite confusing. So yeah, it's not very developer friendly. So let's look at some different tools instead. So basically, what I've learned over the last year of kind of building these agentic apps is I looked at like what tools are available. Especially one of my priorities was TypeScript first, because that's my favorite language to write in. I like doing everything in TypeScript because it makes things very simple. So I looked at like what tools are available using TypeScript for the back end, for the front end that can be used. And the two that I eventually landed on is a tool called Mastra and a tool called CopilotKit. Don't confuse CopilotKit with Copilot. Totally different. Copilot is the tool from Microsoft, right? Yeah, for doing like agentic coding. A CopilotKit is something completely different. So I'm now going to very quickly show building the whole app again, but using a code-first approach. Everything that I'm going to show, let's see, is it? Oh wait, no, before we get into that, I'm going to show something else. So basically, yeah, there's these two tools, Mastra, CopilotKit. Just a quick note on them. They are separate projects managed by separate teams. So I fell into a trap a few times where I thought, oh, because Copilot has a feature, it's going to be mirrored in Mastra. Because Mastra have a feature, it's going to be mirrored in Copilot. Just be aware that sometimes they don't have complete feature parity and play nicely together. But some concepts are the same. So for example, Mastra also has this concept of workflows. So I'm going to show you what that looks like quickly. Basically, I have here, this is actually the project that I've been working on for a while. It's my Storybook Maker app, and I have it running here, I think it should be running on localhost. Yeah, okay, cool. And basically, this is just an app where you can log in and make characters and assemble them into a storybook, right? So I can show you what Mastra looks like when you run it. So it also, similarly to when you have CopilotKit, similar to using Agent Kit, it gives you this nice kind of workflow section for your agents, etc. But I like it because it's integrated into your local development environment. It's not on someone else's server, right? So we can see here, I have my workflows here. So similar concept. I have this workflow here, which is called create storybook, right? And again, it has like a bunch of steps. So it's going to ask one agent to take the input prompt and turn it into a layout and then add some pages, generate some images, etc. So yeah, let's actually do it. I'll run a workflow through quickly. So, and I really like using workflows locally because it's very easy to just quickly debug something and like have it run and run it through. And also the fact that you can use workflows means that you don't have to have everything ready to go, like all the UI built before it's ready. So I have here, let's do it again. Let's just start from scratch. So let's run the workflow. So I'm going to say like, hey, this is the project ID. So I can run it side by side. I just need a prompt. So let's say like, I don't know, Bali adventure, right? And then I just run this through and it's going to run through the workflow. I think the newer version of Mastra actually shows you nicely the steps. This is more like, it will just show me it's all completed at the end. But basically it's now going through each step. I think I can see here when each step completes a little bit similarly to how it works with Agent Kit. And then at some point it will say, yeah, okay, the workflow is done now and here's the output. Here you can see the nodes going through. And then it can even split it out into separate and parallel workflows that will complete, and then you get the output at the end. So yeah, that's how you can use the Mastra Dev Studio. So now I'm going to build the same application again, but using Mastra and CopilotKit. So to demonstrate this, I spent like everything I'm going to demo now took me about 8 hours. And I'm just going to basically walk through the commits and explain what happened at each step. It'll take about 20 minutes, and then we can already break for the break time. So we're going to build the same Session Explorer again. Yep, that can be seen. But this time it's going to be built, developer first, all coded, and then actually deployed to Amazon as well. So yeah, let's show you how I was able to do that. So basically, you can check this out. You can follow that link. The link is available on the Confluence page as well. This is the deployed. This is the deployed application, which is essentially the same thing again. You can say, hi, I want a session on making apps, and it's going to actually give you that result, just like we had with the Agent Kit. Just say, hey, these are the sessions we have. It's a little bit better because I can actually integrate those buttons because I know how to do it because it's all just a React project. So and then you can even download the calendar event. So you can see that, you're able to actually press the save button and open the calendar event as well. And you can see that it summarizes the result again in the widget showing, this is the result. So to start with this, I just started with the CopilotKit starter project, which is actually available on the Mastra. The Mastra made a nice starting point for you to say, hey, this is how you can get started with CopilotKit and Mastra. The first thing I then had to do is copy in the environment files to make it so that you can use it. And then, basically this project here is a Next.js project. It has a I think it's going to show now. So this is the whole front end for the application is a Next.js project. It has the CopilotKit thing imported, and this then reaches out to the Mastra API, which is defined here. And then it's going to reach out to the Mastra runtime, which is the thing that defines all the agents. So basically Mastra on the back end, Copilot on the front end. And then, the actual Mastra is then defined here. So we have create an instance of Mastra, define an agent, and then the agent very simply just says, hey, you are a helpful assistant. So that's really the starting point of the Mastra Copilot project. You can run it and you just see this is what you get. So here we have just one simplification that you can add quickly is that Mastra defines their own server. So as I said, I'm literally walking through the commits here, everything I did. Mastra kind of forces you into this idea of defining your own server, which means that they run the agents for you. But because we're in a Next.js project here, we can literally just we have a backend already. So we basically, rather than saying to Mastra, hey, I want you to deploy this agent server for me, you just run it yourself. So that's all I'm doing here is I'm just saying, connect to the agents which are running locally. And then you can test just from that one change already, then it's already ready to test. So you can now log in to the local application and you can say, hey, I think they already have this thing integrated where you can say change the background to blue or something as well. So you see here, this is called a tool call where it's actually got a front end tool call. You can say change the background to blue. It's going to change the background to blue. So I'll show that a little bit later how that works. So from that, the next thing I did is I just did some simplifications. I changed the so maybe there's a bit too much detail for those of you who aren't web developers here, but this is in this Next.js project. It's always nice to have a proper server. So I basically replaced the file system server with Hono, just to make things a bit nicer. So that's all that's happening in that commit. And then the next thing I really did is just a lot of playing around, etc., and then updated the dependencies. So just updated to the latest version of Mastra, CopilotKit, etc. So that's all the next 10 commits is just doing that. So just doing a lot of updates if you want to follow along. And then the next step was just I already used ChatGPT to generate my first fake schedule. So in order to do that, I just basically said, hey, I'm doing this conference, and then I just give me some markdown to describe the conference. So it gave it to me here. For the PDF, I just, again, took the markdown and shoved it into PDF. So I just generated that using AI. And then the next thing I want to do is I want to be able to embed those documents. So does people here know about RAG? All right, does people heard of RAG? Anyone? Hands up? Yeah, okay, cool, Tucson. So the idea of RAG is that you're actually making semantic search properly, easier to do. So if you think about, I could easily build this session search app by just making it text search, right? I want a session on making apps. Let's do a search through the documents, making apps, right? But what RAG allows you to do is find the closeness of a search without actually having that exact text. So that means that if you have dog and you say oh, I'm interested in pets, then it will go, I'll give you this thing on dogs, even though you didn't specifically mention dogs, right? So the way RAG actually works, what does it stand for? Augmented generation? I can't remember. Do you know, Dusan? Yeah, okay, I think it's research augmented generation, something like that. Retrieval augmented generation. Yeah, okay. Yeah, thank you. So basically, it's then going to do a semantic search on those documents and basically look for things that are also similar. So that's what I actually then do. By the way, this is exactly what Agent Kit is doing as well. It's just that now we're doing it programmatically. We have to write the code ourselves, right? So yeah, this code here is going to have this embed documents script. To be honest, like I vibe coded a lot of this. So I just said to Claude Code, like, hey, I want to do this. And then it came up with this script for me. And I said, yeah, hey, I want to take the content of this document and I want to embed it. You can see that when I run that, I actually don't get any chunks generated because I ran it on a PDF file. And that's another thing that you have to now do because you're in code is you have to parse that file yourself. So it's not, whereas ChatGPT is good enough, you just upload it a PDF and it's already going to say, okay, I need to parse the text from that file. Here, we have to do it ourselves. So yeah, for the next commit, I'm just adding PDF support. And the PDF support is basically going to, I mean, it's simple stuff, right? It's just going to take the PDF and it's going to convert it into text and then do the same thing. So this is me just running it with the markdown file. You can see it now works. It's actually going to create embeddings for that file. And then if I want to add the PDF support, oh, sorry, before I go into that bit, what I've done now is I've created an agent and I've already added the agent with the tool, right? So I already have the script, which is going to embed the documents, but I also need a script to then retrieve a search from that. So I have this vector query tool. I define an agent. We say, hey, you're the camp agent, similarly to how I did an agent kit. And then I provide it with this tool. And the tool is going to use the outputs of basically what it's going to do is it's going to embed the query and use that to query the vector store, right? The vector store being the embedded documents. So this thing here is now just going to actually use a text embedding to search for that. I think I'm skipping over this bit a lot because it's not super important to the general presentation, but if you're interested in RAG, you can search it later. Essentially, all you need to know is that I've added a tool to the agent and the tool can retrieve the results from documents. So now when I run that, I already have reloading the application. I can actually, now already ask it a question. I want a session on making apps. And just like with the Agent Kit demo, it's going to return after a while. So it gives me this it's not in the widget already because we didn't build the widget, but we have the result already, right? So it's going to actually search through that markdown and return me the results. So yeah, the next step, as I already said, is just adding the PDF support. So this at least is very simple. It's just, hey, if the file extension ends with PDF, then pass the result first. So it's not just, if it ends with markdown, then just take it. Otherwise, you're going to have to retrieve the text from the PDF file. And then from just doing that, oh yeah, there's a bug here. I need to create the database. So yeah, there we go. So by the way, for the actual embeddings, it's going to store them in a database, which is just using libsql. So what that means is it's going to take the file and take the content of the file and then store those embeddings in a database. I'll show actually what that looks like in a bit as well. So actually right now, yeah. So now I just changed this to Postgres because I actually want to deploy this application. So I can't just use libsql because libsql is only going to be like a local file system. So this is at least very simple to do. You can see that all I have to do, like Mastra provides this thing called the libsql vector, and I just replace it with the Postgres vector, right? So I now say, instead of embedding them in file, them storing them in a local database, and this is just a deployed database, which is on Neon. It's free. So yeah, now means that it's going to search through that PDF and embed the documents. And when I actually run that, then we should see that it's now going to store them in the database. So when I open this up in the database, I can see that I'm going to delete all the rows just so you can see that it does actually work, and then re-encode them, re-embed them. And we can see now in the Postgres database that the RAG chunks are there, right? So very simply, what happens is it chunks based on how you define it, chunks the document up into 36 chunks, I think in this case. And then for each of those strings, it stores an embedding. And other searches or other text strings will have a similar embedding. And that's how it's able to do this semantic reasoning. So when you search, like, I want a session on making apps, it will embed that and then say, oh, it has a similar embedding to this row in the table. And that's how you're able to retrieve the documents or the search results. So yeah, that's how the embedding works. You can see the numbers there, and each of the strings from the PDF are then encoded. Maybe I can, yeah, okay, cool. And then the next thing I did, I think, is already to basically deploy this. So I'm going to skip a lot over the deployment code, but basically, in order to deploy this full stack application, I added some infrastructure as code, and then it can be deployed. So it looks like a lot, but it's basically just, yeah, changed it into a monorepo. Have to move the environment folder as well because it's now a small app as part of a bigger app. If you look at the README on the code, you can see here exactly how the project is structured. So let's just skip forward a little bit. Now I can run this deploy, basically. And once I run the deployment script, then we should be able to see, deploy dev is now going to be deployed to AWS. This uses OpenNext, by the way. If you want to deploy a Next application for free, it's great. So now, it's been deployed. And that's it. Like, we already have a good starting point to the same thing we have with Agent Kit. I can now say, hey, I want a session on making apps. And it's going to give me the result by searching that document. Also, what's nice is if I want to replace the documents, I don't have to deploy the whole application again. I just re-embed them, right? So I have this local script, which is embedding documents. And then if I want to replace those documents, then that's how I do it. I just re-embed, and then when you search online, it will have them. So for the next steps, I'll just skip over quickly. I just basically set it up for a good vibe coding environment, added some MCPs, because what's nice is Mastra and CopilotKit have a docs MCP server, which means that you can vibe code with them really well because they just explain. And by the way, if you want to vibe code with them, here are those docs. So you can add those to Claude or Cursor or whatever. And then if we do have time later to try and code something out in this, even for people who aren't web developers, you can really just, hey, make the agent do this and it will work. So the next thing I did is I just added shadcn. So shadcn is like a very nice component library. It's similar to Material UI, but better in my opinion. And it's also very well understood by AI apps. And then, so the next thing that needs to be done is we actually need to then format the response from the agent into this nice JSON, just like we did in Agent Kit, right? So in order to do that, we have this session formatting agent, which is being added. And you can see now that when I do the search, instead of just having it in this unstructured text, it's actually going to say, this is the response, and it's going to give it to me in a nice JSON format. So whereas before we just got like similarly to when we first did with Agent Kit, now we actually see this is the search, this is the result, nicely formatted in JSON, and it takes a while to respond. But then we have, there we have the actual response formatted nicely. So how that's actually done is I added this new agent, which is, I think, going to be shown now. So there's this new agent. It's called the session format agent. And the session format agent, what it does is it says, hey, you format JSON, right? You receive unstructured data, and then you format it into a nice, session speaker, start time, end time. That's your job, right? So I've defined that agent and then integrated that with the tool call. So the tool call, rather than before, it would just reach out to the vector store directly. Now what that does is it actually, will do the same thing as before, search the documents. But then after searching the documents, it's going to say, get the result from those documents, get those embeddings, and then run those embeddings through the session. So here we have the session format agent, run that through. So you see that it says get this agent and then pass the result from the search into that agent and then get the results. So that's now going to forward the results from the search to the agent, and then it's going to format it. So we can see the agent here. It says, you say this is a very nice Zod library where you basically can pass strings in a very nice way. So you say, hey, you're going to receive a string like this, which is very unstructured. And then I want you to pass it into a nice response, which looks like this, right? So that's all I'm telling that agent to do. You have to be very explicit, by the way. It just flashed up on the screen there, but when you try and use agents this way, be very explicit. You say, hey, make sure you only return JSON. Because if you don't do this, it will be like, hey, I've summarized this for you. And you just want to take that JSON and immediately throw it to the next step, right? So I always find this very useful thing to add at the end. Do not include markdown, commits, or any other explanation. I only want the JSON object. So by doing that, you're able to actually take the result. And you can see there, we have the nice formatted JSON being formatted by the session format agent. And now I just need to actually use that on the UI, right? So how that works with CopilotKit is they give you this very nice use Copilot action hook, right? And what you do is you just say, hey, whenever this message gets called on the server, this is how I want you to display the result. Because the thing you have to understand is that message still comes through to the front end. That message says the server called this client tool, which was to search for the database. And normally you wouldn't see it because you don't actually want to see that, right? But you can hook into Copilot and say, yeah, I actually want to display that. So by doing this, you're basically saying, yeah, this is the schema, this is how it's going to look, the session schema. And then I can define a UI component on the front end. And that way that text, that JSON object will actually be displayed to the front end. So then, yeah, this is just some cleanup. So I can define a separate component to actually display this. So this is a React component called my session widget. So remember earlier I was complaining about how Python is not a good way to define these widgets. I much prefer doing it in React. So I define this component called the session widget. And I say, whenever this tool gets called on the server, take the result and pass it into this React component. And there, yeah, for the session widget, I'm now just going to actually make it nice. So for the next step, I just used V0 to make a nice user interface. I know please give me another 5 minutes just to finish the demo and then we'll do the break. So yeah, now I just defined the user interface, making a nice component for it. And I now have this compact sessions widget. So this compact session widget is just made by V0. V0 is a great vibe coding tool. I literally just gave it, this is the schema. It's going to return this schema like the JSON and then build it for me, right? And then it does the one shot, right? So that's a very nice way to just make that nice sessions widget. And now you can see the same thing. So before I just had the JSON displayed to the screen. Now I have the nice widget showing, and now I just want to make this save button work. And then, because we're already now at the same place we were with Agent Kit, right? Granted, it took me a few hours, but it's so much more control to do, right? So I just need to actually make it so that when we click that save button, it really gives me a nice calendar event that I can use and I can save it. So yeah, I want to now save the calendar event. So in Next.js, we have this nice thing called server actions, where you can reach out to the server and say, yeah, this is what I want you to do. So that's what I've done here. I've just defined this save session function, and the save session function is going to call my backend on Next.js and call this server function called download calendar event. It's going to pass in the result from the tool call, and then this function is going to take that and make it into a nice calendar event so that you can download it to the client. So now it should be that when I click the button, so now I say, hey, I want a session on making apps. And then you can see it returns me all those sessions. And then when I click save, I get this iCalendar event and I can just preview it online. I just drop the file in there. And yeah, it says, so you think the time is wrong? It says it starts on the 1st of October. It should say 6th of November. And that's the problem that you have with doing it this way. Honestly, this isn't the best use case for, like, you'd better tell the AI, these are all the sessions you can pick from. These are the start and end times. Pick one, rather than getting the AI to create that object based on what it found in the documents, right? Like, it's actually not the best use case here. But this is still a good example of how you can take something unstructured, add some thinking to it, and say, okay, probably what you meant was the 6th of November, which is what I'm essentially going to do now. I'm actually going to tell the agent, hey, you have to pick either 6 or 7 November. Don't pick 1st October, right? But yeah, that's not actually really the best way to do this. But yeah, that's what I'm going to do. So I'm now going to fix the dates. And in this section here, we just say all times must be in this format, and you must pick either the 6th or the 7th of November, okay? And that's actually going to kind of work around, fix this problem. If I have time later, I might show an actual better way of doing this, but I still think it's a good use case, as I said, for taking something unstructured, thinking, and then saying, this is what you meant, right? So I want a session on making apps. And then, yeah, now we have the sessions and they say the right time, right? So now it says 6th of November, and then I can save that and open it up. And yeah, it should now say in my iCalendar event, 6th November. Cool. So yeah, that's already the end of that bit. That shows you, I mean, I know I blitzed through it very quickly, but that was really like 8 hours of work, just going through the commits exactly how I did to build exactly the same thing that Agent Kit can do for you in 20 minutes, right? But with a lot more control. So yeah, I think now time for the break. When we come back, I'd like you guys to actually check this project out and see if you can play with it a bit. So I think especially if you don't have the project checked out and you want to do this, then you can check it out. I think maybe we can kind of split into the people who are confident web developers and the people who aren't, because I think if you're a good web developer and you already know a bit of React and Next, I think you'll get a lot of value from this project. If you are not, then I think you'll get much more value from the OpenAI Agent Kit project, right? So if you're like, yeah, I know React, even if you don't know React, you can vibe code it very well. But basically, if you're someone who likes to develop and get into the code like me, then definitely try and check out the project. If you just want to get an idea of how agents work and drag and drop stuff, then you can use the other project as well. So maybe if you decide over the break which one you want, and then yeah, Yeah. Okay. So yeah, we can start. Try me back at 3. We'll start again at 3:05 because I don't want to take 5 minutes off your break. Okay. Cool. Good. So guys, I know that not everyone's back yet, but I just thought for the next bit, I'm just gonna give a assignment, like a practical bit to do anyway. So if everyone's here, we can already get started with it. Or, for people who come back, I can introduce it to them. I'd really like that if some people can accomplish it early, then they can help out the others as well. Because I know that there's a few people here who are much more experienced in web development than others, maybe. So yeah, basically for this next part, which should only take about 10 minutes, is essentially the issue with this application up to this point is it's quite slow. Right? So it actually takes about 45 seconds to pass your response, which is insane. If you tried it already, on the main branch, it's okay because this is already fixed. But if you see on the GitHub repository, there's actually a branch called task2. And if you run that one, and that's what I demonstrated here, it actually takes about 45 seconds to process your request, right? So obviously you can cheat. You can just look at the main branch and see the diff, right? Or you can check out task2 and actually see if you can make it faster. And to give you a hint, there's really two. Oh yeah, and by the way, and also not only is it slow, it's also not very accurate. So I think I have an example here. I want a session on lions and tigers, right? You can try it yourself on that branch, right? Ask it for a session on lions and tigers, and you'll see it still gives you like 6 sessions, right? And that doesn't really make sense. So the task is improve the speed and the accuracy of the results. Okay, and you can, if you look at the presentation slides, you can already see a hint on the next page. The hint is, well, does anyone want to guess? How do you think you might speed this up? I'll give you a clue. Right now, it's using GPT-5 Nano with reasoning to pass your response. So you can change the model, right? You can change it to I think a good one to try is GPT-4o Mini. It has IntelliSense there, so you can see what models it. Or what I did is I literally just copied the code into ChatGPT and said, make this faster, right? Which model should I use, right? And it's like, okay, use GPT-4 Mini, turn the reasoning off, right? So that's what you can do. So find in the code base where it is that you specify that. If you want help, you can ask me, or all the answers should be in the YouTube video, which you can also see there, right? I know I blitzed through in like 20 minutes, like literally 8 hours of coding, right? So at least that video is a bit slower paced. So if you get stuck, you might find an answer in there. And yeah, have a go. And then also for the accuracy, that might require a little bit more understanding of how RAG works. But you'll actually see that when you do that search, you actually get back a property called score, which is the relevance to your query, right? And that's actually a number between 0 and 1. So right now it's set to no threshold, right? Which means that anything that remotely similar can, and that, by the way, if you're interested, that number is actually a score of the distance between the vector of your query and the vector of the response. So every chunk of that PDF document gets chunked into that database and gets a number. And that number, that array of numbers, that looks really complicated, will have a distance from your query. And if that distance is high, then it's not the same. Whereas if the distance is small, then it will return that result. So you can tinker with both the model, and you can also tinker with the threshold. So for the threshold, it's like a normal TypeScript filter, right? You just say filter the results, only return the ones that have a higher than 0.2 threshold or something, right? So that's something you can try. So yeah, that's the task right now. I'm just gonna float around and see if you guys are able to do it. Yeah, so let's carry on. So how do you do this interactive task? I will show you now. Let's open up the main branch. So yeah, so you should be on the task2 branch if you want to follow along. Okay, yeah, so here's the solution to the task. So you can see now if I say hey, I want a session on making apps. This is gonna take about a minute to respond. What I'll do quickly is just talk about the solution to this. So as I hinted at already, the solution is to use a model which is going to do less reasoning, basically a faster model. And then also if we want to get more accurate results, then we should use a lower threshold, right? So in order to do that, I can say, okay, it's finally only just now doing the search. I'm not going to wait a minute for it to respond. I'm just going to skip ahead. So let me come in here and go to the next commit. All right, so let's look at the changes that are made. So the first thing I actually did to get this to work is I just added some logging, which is always useful to see how long things are taking. So I'm just going to revert my change here on the agents just for the example. And you'll see that when I run that query the first time, right? And I say, hey, I want a session on making apps, then it's now going to log because I added some logging code in my query. I'm just going to log out. This is a pretty standard way of seeing how long things take. You just take the time now take the time when your thing finished and then log out the result, right? So I can see in my output here, if I just search for time taken. So time taken to search the documents is only 2.8 seconds, right? Not bad, right? But you'll see after 40 seconds, it's going to say time taken to parse the documents is 40 seconds, something like that, right? So very bad, right? Let's see, is it done yet? Still not done, still not done. So yeah, we have all the chunks logged out there. Let's see. Yeah, still, you can see in the app, it's still searching as well. Okay, so time taken to format result, 40 seconds, right? I hope you can see that there. So, okay, so how do I speed this up? Well, what I did is I made these changes into the agents. So yeah, there are a few things that you can pass to the agent to make it faster. The first one is we just changed the model. So I switched the model in this agent. So if you want to follow along, the file here is web app, source, Mastra, agents, right? And basically, if you switch the model here to GPT-4 Mini, for example, or a Mini, then already you're going to be much faster because this one's not going to have any reasoning, right? So reasoning is where the model like reprompts itself and tries to work out, right? Not necessary when you were just giving it some simple text and asking it to format to JSON. There's a few more things we can pass in here. The first one here is temperature. Temperature is interesting. What temperature is a so you can see here we can provide provider options, right? That's the first thing to mention, right? So before we were providing provider options, effort was low, right? But now we are also providing temperature, and temperature is the creative license that you're giving the model. If you have a temperature of like 1, you're basically saying like, every time you give a prompt, it might give something totally different, right? Like it's being creative, right? Obviously for this task, we don't want it to be creative. Like we want one-to-one. Like if we give it the same text, it should give us the same result every time, right? So that's something that we can specify. And then the other thing is verbosity, which is just about how long you want the model to respond. So if you say low verbosity, it's gonna like give you less, like be less verbose in its answer. If you're looking for more stuff here, then you can actually you can look at the platform API, OpenAI references here, and you'll find all the stuff you can pass in, right? So you can pass in temperature, etc., right? So yeah, here you can see all the API specs that you can pass. So that's the way. So now, like if we do that again, so now that I have that change, I think I just have to save and restart. Then we should see it's much faster. So if I again say I want a session on making apps, then again, let's look in here how long it's going to take. So we should have now, yeah. Time taken to search the documents is 2 seconds. Same again, we didn't change anything there. But you can see that we have the results much more quickly. And if I look here, time taken to format 6 seconds, right? So that's a massive improvement. We had went from 6 seconds. So just to show it like from how it looks in the UI, much faster, right? So if you say session on making apps, you'll see that 6 seconds feels a lot more responsive than 10. It's still not super fast, and there is a few more things you can do to make it. And you can also see it takes quite a long time to decide to do the tool call, right? So, and that's not included in our response, right? So if you wanted to optimize this further, you could actually change the agent which is deciding to call the tool, right? Because we have 2 agents here, remember. We have an agent which is going to search the tool, and then we have an agent which is going to say, oh, I need to search for documents. And we have an agent which is formatting the results, right? So yeah, so you can see that was much faster, and it's returned like all these mock responses. The second thing was we want to make it more like we want to make it more accurate, right? So if I say right now, session on lions and tigers, oh, didn't even spell it right, but it's probably still going to give me something. Then hopefully with this other change, we're going to make that not respond anymore. So if I do that right now, I think it probably will return me some sessions, lions and tigers. It's interesting, by the way, that you can see that the first agent has actually corrected my typo here. So I put tigets and it's still responding me something, right? So yeah, not good, right? So how do we improve this? Well, what we can do is we can do this, right? And what we are essentially doing here in the vector tool call, we have this new property, I called it score threshold. And all we do is in the results, which comes from this function which searches the documents, we say, for the results, I want to filter out and only have the ones that have a higher than 20% relevance. So if you want to follow along how to do that, you need to do it in the vector query. So that's the vector query tool call, which is in the source tools vector query. So if you want to, you can introduce a score threshold, and inside the results, instead of before where we just returned the results, now we do results.filter, result.score is higher than 0.2, okay? And now if I try this again, I don't know if this is going to work, but let's try. So session on lions and tigers, then hopefully we shouldn't get any results, right? Because there shouldn't be any results which have a high enough threshold. I'm not actually sure if this is going to work. Okay, we still get one, not ideal, right? So obviously, like, you could play with that threshold a bit more. You can increase it, but if you put it too high, then obviously it's not even going to return the relevant results, right? So it's a tuning thing, right? So probably 0.2 is not high enough, but if we set it to 0.9, then we might never get any results, right? So, yeah. Okay, cool. So that's the interactive part. So now I'm going to talk about user agent interactions. For this part, there's actually, I encourage you to do this. There's a link you can follow from the slides and you can have a look at this. It's already a deployed application which the CopilotKit guys have made. When you're interacting with CopilotKit, you have a few things that you can do to hook into what the agent's going to do. So there's different types that you might want to hook into in terms of displaying the result of the tool call to the user. So the first one you have is use render tool call, which is custom rendering for a tool which is executed on the server, right? So custom visualization for a server call, which we already did, by the way, right? That is what we were doing with the search documents, right? We say, hey, when someone calls this, we want to show the result. Then there's this also thing called use human in the loop. You use this when you want to intercept an action that the agent wants to take, but you want the user to be able to intercept and maybe change what the user wants to do. And then there's also use front-end tool, which is something where the agent it got two use cases, right? Either the agent is asking the client to do something, or the front end is asking the agent to do something. So they're actually two different use cases for the same thing, right? So what I encourage you to do, right, is let's actually everyone open up this deployed application. And by the way, for each of these things, right, where we have use front end tool call, whatever, these are just hooks from CopilotKit. Obviously, this is not like that standard. This is how they imagined how you might want to use these things. So it's not standardized across every library, but I still think this is a good way to think about how we actually display to the user what the agent is trying to do, right? So yeah, I would just say play with these for 5 minutes and see if you can. So there's 3 examples here, right? There's the agent, so you can just chat with each one. There's the agent chat where it has a front end tool call. I mean, it already tells you what it is, right? But for example, here, I can say change the background to blue. Does anyone know which one of these 3 that is? Do we think it's use front end tool? Do we think it's use human in the loop? Or do we think it's use render tool? So the question is, out of these 3 examples, right? What are we doing when we say to this agent, change the background to blue, right? Are we displaying something on the which is happening on the server? Are we getting the user to intercept and change what we do? Or are we getting the agent to change something on the front end? Yeah, it's use front end tool. Yeah, it's this one. It's this one here, use front end tool, right? Because what we've done is we've defined and you can see in the code here, you can look it up, right? The code is there as well, you can have a look. What it's doing is it's saying, yeah, I just provide this tool call to the front end. So if you think about it, this is quite powerful because you can essentially take any app where you just have your, maybe you have an app like Canva where you say that you can drag and drop stuff around, right? You can take anything that the user can do and you can plug that in as a use front end tool call to the agent. And now suddenly the agent can control your front end, which is quite powerful, right? So that's that example, right? So then obviously this one, like, it's quite clear from the name of the thing, what it is, right? It's called human in the loop example. So the example here is like, you say like, make a sandwich, right? Make a sandwich, which is spelt wrong, but hopefully it gets me. And then you see this is human in the loop, right? Because what it's doing is it's saying intercept what the user wants to do, and then you can change, right? So you can say, I want to do this instead. And then you say perform steps, and then it will take just the agent that the user said. There's a bit of a UI problem here, and then forward that, right? So that's how you can basically intercept from the front end and pass it to the agent. And then the final example here is, I'm a haiku generator, how can I help you? So let's say like butterflies. Yeah, and then it immediately comes back with a response, and then I can apply it and I can get it into my little thing. So it's come up with a haiku. So anyone wants to guess which type this is? We have use render tool call to show from the server, use human in the loop, or use front end tool. Yeah, so this is a front end tool as well, but it's kind of confusing because it's a front end, the other use case, right? Because 100% right. But if you think about it, it's slightly different because this is the front end asking the agent to create me a haiku. So, and then I will display it, right? Which is not quite the same as the agent saying, just do this and then render it on the front end. So that's 2 subtly different things, right? But actually how it looks in the code is quite interesting. So if we go to the code here and have a look, where we have, so they changed the name of the syntax a little bit, right? But you can see here in the use Copilot action, so this is what it used to be called, that we tell it, hey, generate a haiku with an English translation, and then these are the parameters I want to return, right? So this is like the front end telling the agent what it wants to do, right? Whereas the other way around is more like the agent telling the front end what it wants to do. But so there's two subtly different ways that you can do similar thing. Because it took me a while. I thought this was very confusing to start with. But if you really think about it, to the agent, it makes no difference whether the back end is telling it to do it or the front end is telling it to do it. The only thing it cares about is that the result goes to the front end, right? So that's where you have those two slight differences. Cool. So yeah, you can play around with that. You can look at the code. Just to note that the API is slightly changed. Let's look at sharing from the front end to agent/tools. Right? So let's say you have something on the front end and you want to share it to the back end. So an example of something you want to share to the tool might be something like an auth header, user ID, that kind of thing, because the tool has to verify like, hey, user wants to edit a post. Do they have access to actually do that, right? And then there's also something that you might want to share to an agent. So for example, like, let's say you're doing a travel booking app, then obviously you might want to share to the agent, like, this is the current holiday that they have planned, or this is the current items they have in their basket, right? So basically, when you're getting, for each of these things, if you then want to get fresh data, if you're using it in a tool call, then you can just fetch it manually with a tool call that needs it, right? So let's say you have something like you're working on a basket, you just send the basket item to the agent network, and then in the tool call, it will fetch. You have the tool call says, I have the basket ID, I can now fetch the contents of the basket. The other thing is you can have the agent reach out and get it itself, right? So what I mean by that is the agent says like, oh, for the next task I want to perform, I need to know the contents of the basket. So you can give it a tool call to say, get basket contents. And when I say you can spoof this is actually quite a common way that people do, is what I mean is, remember what I said about earlier about agents just not really having memory, right? You just tell them always the whole history of the conversation. So when I say spoof a tool call, what I mean is you say to the agent like, hey, you like summarize the contents of the basket. You called this tool to get the contents of the basket, and this is the response you got, right? That's totally valid. You can do that. So you don't actually have to wait for, if you know the agent's going to need this data, you can just spoof it by saying like, you already did it, and this is the result you got, right? You don't actually have to wait for it to make the tool call. So that can be a bit of an optimization you can do. But I would prefer most of the time you can just inject it in the tool call. So when I say inject in the tool call, I just mean the API somehow knows the basket that it's looking for, and then in the tool call, you just reach out the data you need, right? So does anyone have any questions on any of this? Because it might be a bit confusing, but I will show some examples in a bit. Okay, I hope I haven't lost everyone. So yeah, I'm just going to demo this quickly. We're going to pass the session ID to the backend, and I'll show you what I mean by this. Let's check out the main branch, stash this. Okay, so someone asked me earlier, what the heck is this session ID thing, right? And that's on the main branch. And I'll show you what that is now. That's just the example here. So what I've done here, and I'll show the result in a second, is just through the CopilotKit front-end SDK and the backend, is CopilotKit has this thing called properties, right? Properties, so if you know React, this should be pretty simple stuff. We have session ID, we have set session ID, and then we have a button, which when they click it, it just sets the session ID to a random session ID. That's all that is, okay? So now we want to use that on the backend, right? So how we do that is we say to CopilotKit, we pass this as a property. So my point, the thing I'm demonstrating right now is you don't have to pass everything through the prompt, right? You can give it the context outside of the prompt, right? Because most people, when they first do this, they would just think like, I'm just going to pass in the prompt, here's a session ID. But that is going to confuse the agent because it doesn't need to know, right? It doesn't need to know that, right? You can pass it. If you know that your tools are going to need this, you don't have to pass it through the agent. It's going to confuse the agent. It's also going to cost money because you're giving the agent more tokens, right? Here, it's already good that we pass it session ID. Session ID could be anything, right? It could be an ID that retrieves 2 gigabytes of data from your database, right? So much better to pass that around the model, then pass it to that 2 gigabytes of context to the model, right? That's the point I'm making here, right? So we can pass in this session ID, and then inside the endpoint, it gets a little bit more complicated. So before we were basically just routing that request directly to Mastra, right? Now in this code, what I'm doing is I'm extracting the body from the request, right? So request comes here, we extract the body. We extract the properties because they're stored here, right? So this is just how Copilot mangles your request. right? This is very specific to how they specifically are doing it, right? They'll take your message history, your properties, your whatever, and send that together as one object to the API, right? So we take all that, and then what we can do is when we create the Mastra runtime, we inject this runtime context. So we're basically like taking this idea of context, like from Copilot, and forwarding it to Mastra. And when you inject things like this, in your everywhere where you have agents, everywhere where you have tools, everywhere where you have anything in Mastra, you can actually receive the runtime context. So in this agent description, where before I just had some instructions, now instead of instructions just being an object which has the content, my instructions is now a function, because you can write it like this instead, which receives the runtime context. And then in the system prompt, we say the session ID is this. So you can see here in the system prompt, I say the session ID is runtime context.get session ID. So this runtime context is forwarded through the API call to Mastra, and now you have it everywhere. You can use it in every tool call, you can use it in every agent, you can use it in everywhere, right? So what that means is if I now go to my application, where is this running? 3002. Let's open this up. Okay, I can close some of this stuff. Don't need, it's taking a while to do the first render. Okay, so you see that this is just React stuff, right? Like I have the session ID, remember? And here I can now ask the agent, like, what is the session ID, right? And it will, because it's injected from the system, bear in mind, so now this agent, the very first prompt that it had, remember agent is just model plus system prompt, right? So the very first prompt that this agent had is, hey, I want you to be a helpful, nice agent, and the session ID is this, right? So now, and if I now change this, and I say again, what is the session ID? Then now the system prompt is saying, hey, you're a helpful agent, blah, blah, blah. The session ID is this, right? So you can see that it's updated, right? So this is a very powerful way of basically like keeping the working memory with the agent, because here we just have ID, but ID could be representative of a lot of data, okay? Like it could be anything, right? So that's how you're able to do that. Obviously, like when you first start with this, you would just think, I'll just pass the ID through the prompt, but that's not the best way of doing it, okay? This is a better way. And because if you're doing this very complicated set of agents, you can then pass that session ID down anywhere you like without having to pass it through the tool call, through the next tool call, to the next agent, whatever, right? So yeah. All right, anyone got any questions on this? Okay, so that's that demo. So quick note on authentication. So you should authenticate your API calls. So this is why Next.js, I know I'm leaning very heavily into Next.js in this section, right? But it's very powerful in this case because Next.js gives you that whole full stack experience where you have front end, back end. If you are a front end developer and you like working React, obviously just think of Next.js as if you have your React application and your Express server, right? That's it, right? But the important thing is, like, I would not really think, unless I was building something very simple and probably not really trying to go to production with it, I would not build an application which just has React front end and then talks directly to the agents. You want to have that middle layer. That middle layer is essentially saying the user wants to edit a post. Are they allowed to do that? But you don't have to tell, like, that just happens by your Next.js middleware, because essentially what you're doing is you take the auth header that the user has and then you say, okay, they're going to execute this, that, and the other. And then, yeah, like if they get back a 403 saying doesn't have access, that will go to the agent and the agent will just return, like, you're not allowed to do this. So that's how you can ensure, like, you never just put unprotected tool calls directly from the user, because you need to verify, is the user allowed to do this? And when you do it in this way, this structure, I'm sure there are other ways of doing it, but like this is a very nice way for you to just handle the authentication side of things, right? So yeah, role-based access control, that's basically what I just mentioned, right? So for example, like only a creator of a post can edit the post, that kind of thing, right? And then, but the other thing you have to think about, not just in terms of whatever setup I'm talking about now, but specifically when you're doing any AI app, is things like API security patterns and rate limiting to prevent abuse become more expensive. Because I got a question from you guys earlier, like, how much does this cost, right? And you have to bear in mind, it's not free to run these APIs, right? So you should do rate limiting, because you don't want someone to spam your API and just cost you a lot of money, right? So whatever you can do, you should rate limit. You should think about, least access control, etc., and make sure that people can't just spam your endpoint and cost you a lot of money. So yeah, some more intermediate concepts of agents. So now we have this idea of working memory. So the idea with working memory is, again, there's a few different concepts of how people describe this, but basically your working memory is part of the context and it's the agent's evolving task state. So you can think of this as, like, if you have a travel planner app, it's going to be the flights, the seat numbers, the hotel bookings, etc., right? So remember, like, memory is not real. Memory is just context, right? So part of memory might be the historical messages, but also now you might have an agent which is doing something like editing the travel holiday you have planned. So that's what working memory is. So it's often updated with tool calls, which may or may not involve invoking other agents. It's important when you think about agent memory to think about the structure and that everything that can be deterministic should be, right? So a very bad use of an agent would be, here's a shopping cart, total up the amount that it should cost. That's a terrible thing to do with an agent, right? But you can calculate that, right? You should calculate that. It will almost certainly at some point make a mistake adding numbers together, right? So that's what I mean why I say like everything that can be deterministic should be. So if you must have a shopping cart as your working memory, then you should, you have the items and maybe the product ID, but the product ID will be linked to a separate price. And when you want to sum up the items, then you sum them using your database, using the information you know is true, not asking the AI sum up the price of these items, right? And so that's what I mean when I say it should be structured, and you should have deterministic updates and also structured output, right? So if you are doing an update to that state, then ideally, if you do something like add this item to the shopping cart, you should get the same result every time and not like some weird summary is different or whatever, right? So be as deterministic as you can make it to help with things. Yeah. So think about how you can make your state deterministic. So complex tasks can be carried out by multiple agents. So again, earlier when I was floating around, I got a question from you guys like, can you set up a multi-agent approach where you have one agent then routes to another agent, right? That's what a router agent does. So you might have like your entry-level agent, which is saying, hey, this is your task, but you have ability to route to different tool calls. So that's what a router agent is. And then you can have specific agents to handle different sections. So that way you have a clear separation of concerns. You have controlled context windows, which don't just bloat, because if you try and do everything with one agent, then that context gets huge. And also it's much easier to scale, test, and audit. So think of, this is what I meant when I said right at the top of this workshop that it's like the lessons are the same. It's just like microservices. We don't, in this day and age, normally create one massive service to handle the products, the baskets, the everything, right? We create microservices and spin them out, right? And that's exactly the same here, right? Is don't create a monolith agent. You can start with a monolith agent. That's a good place to start because you'll see how it goes, but then you can split stuff out. So that's quite useful. So yeah, I'm now just going to talk about a case study to kind of introduce this concept. So let's imagine that you have, I actually work in Zorke in the Building Construction Authority. So this is what I use. We're not doing this, but this is how I thought we do deal with these files, right? These like 1 gigabyte building specification files, right? So this is not a real use case. Like we're not actually doing this in our project, but I was thinking if we wanted to, how we would do it. So let's imagine you have a 1 gigabyte architectural plan, right? Huge. And there are hundreds of doors, floors, fire safety, annotations, whatever, right? And you want to automatically fix things based on fire safety, compliance, etc. So this is an example of like working memory, right? So we want to make a system that can reason, edit, and update this design. How do we do that? So most people, when they first start thinking about this, would say monolith agent. That's what I'm going to do, right? So this is my monolith agent, and you just tell, just like you would ChatGPT, like you are an architectural design agent. You read, write specifications, verify doors, layout materials, lighting, and costs. Do it all, do everything, right? And then your architecture is obviously pretty simple. It's just, user request, monolith agent, handle this task, and then done. So that's how you would do it. But obviously this isn't very good because every time there's a prompt, you're going to force 1 gigabyte of that whole building specification into that network, right? We have one agent to cover everything. So we're going to get context overload. We've got mixed goals. So it's trying to edit, reason, summarize simultaneously. It's not deterministic because obviously you're going to get different stuff. And it's also really hard to debug because like imagine trying to trace through that spaghetti prompt, which is going to be huge. Like, oh, I didn't do what I wanted. What you end up doing is like, starts out well, but your prompt just becomes insane because your prompt is like, if the user is asking to summarize, do this and this. If the user is trying to do this and this, do this and this. Your prompt becomes like an essay, right? And then you realize that like, I changed one thing in the prompt over here because it's not summarizing very well. And suddenly it's not doing something else very well. And it just becomes like whack-a-mole, right? So it gets very difficult. So a way that you can improve this is you can do the multi-agent approach. Right? So this is how I would think about this, right? Instead of doing one overworked agent, I would split this out. I would have the layout agent, the fire safety agent, the lighting agent, the summary agent, right? Something like that, right? And you have very cleared roles out for each one of those agents. And each agent then only sees part of the data it needs. It's faster, it's auditable, and can give you like a more narrow domain for each. Just think about this, like if you actually had a team of people working on this task, you wouldn't ask one person to do everything. You would be like, okay, you're a specialist in fire safety regulations, you're a specialist in this, you're a specialist in that. And it's the same here, it's the same. So this would be my approach. So you have your user who gives the prompt, like fix all the doors on floor 1, right? You have your router agent. So usually the router agent is just an agent that has some tool calls, and the tool calls will route to each of these, right? So you give the router agent, here's some tool calls. You have the layout tool, you have the fire code check tool, you have the lighting analysis. That's how it can route very easily to different things. You might also just say, if it's a very simple query, you can just respond directly, right? You don't have to route to a tool call, right? And then, yeah, you have your different things, and then they would write back to that thing, right? Right back to the building specification. In terms of when you actually, let's give an example of the fire safety agent, how you would actually then do that, right? So what a fire safety agent would do is it would extract all the door entities from the spec, right? You do that deterministically. You don't ask the agent to do that. You do that. You say, okay, here's the 1 GB file. I'm going to pull out using SQL or whatever. I'm going to filter out all the information related to doors. You can do that yourself. You should do that yourself if you can. Then you can abstract on that. So you can feed that to the agent and say, here's all the building, here's all the door stuff. Is it good? Does it meet the compliance? Does it do whatever? And then the agent can say, oh no, these doors are all too thin. We need different material, and we need 2-inch thick fire retardant doors. And then you can reapply those edits back into the original 1 GB massive architectural plan. So you've basically said to the fire safety agent, I've carved out a slice of this huge context for you to work with. Tell me what you want, and then reapply it, right? Much better than saying, hey, you are the God agent who does everything. Here's a 1 GB file, make it so, right? It's not going to work very well, okay? So yeah, the other massive advantage of this, which we've already seen when we were using Agent Kit, is you have targeted reasoning power, right? What I mean by that is if you have the summary agent, which just summarizes the specifications or whatever, probably don't need to use GPT-5 reasoning high, etc., right? Like overkill, right? You can probably just use like 4 mini and get a very quick response, right? So just like with microservices, where we make things scalable and we say you need to use higher CPU utilization, you need lower CPU utilization, same principle applies. You need more reasoning, you need less reasoning. That's how you can speed things up. So yeah, does anyone have any sections or any questions on that section, or I can move on to the next section, which is about streaming? Yeah, go ahead. Sorry. Yeah, it's going to fan out. Yeah, sorry, say the last bit again. So, I mean, that router agent is prompt plus model, right? So that router agent already is an LLM. Like, yeah, that's what that is, right? So yeah, like whenever I say agent, all agent means from the description of the top, agent is model plus prompt, right? I just mean that like, if you want to use that router agent to decide what to do, you don't have to use tool calls, but that's a good way of doing it, right? Because for example, you could like say, export this JSON format, and then based on that, if else, blah, 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 like we did with Agent Kit, right? But a nicer way to do it is just register a bunch of tools that it has access to. But the thing that I'm saying is different about this approach is rather than saying to that one agent, execute this tool call, you tell that agent, use this tool call to talk to the fire safety agent. You don't pass it anything. It knows what it needs to do. Just pass it the query, right? You don't need to pass it the context. You don't need to just pass it the prompt, which is make it regulation safe, right? That's the difference. If you're using the monolith approach, you say, pass it everything, pass it what the changes it needs to make, pass it everything it needs to do, right? Whereas with this approach, you just say, forward that prompt to the model fire safety tool, and then the fire safety tool will get from that 1 GB file the context it needs, apply the edits, return. Yeah, does that make sense? Yeah. And if you think about how this makes things better, it's exactly the same as like, the router agent is basically the project manager, right? And he has his experts, right? You can see why it really saves on context as well, because imagine if you're the product manager and you ask someone in your product, like, can you please write me these Figma specifications? You don't need to know everything he thought as he was doing that. You only need the result, right? You just need to know, okay, look good, not looks good, make it better, right? So if you just think about that as imagine you're the product manager, not only like would it be complicated if you were trying to do everything yourself, it would also be complicated if you had to maintain every decision that was being made, right? You just need the input and the result, right? And you can see how that massively saves on context, right? Because each of that, response, you just get what I asked you to do, what you gave me back, right? No, fix it, do it again, right? And you don't suddenly have gigabytes of context, right? Which is going to make things slow and confusing. Yeah. because I want you to understand the cost of context, right? Like every time you say to the agent, I want you to do something, that context is expanding. You have the whole history, right? So if you make something which is not economical about context, you might say, okay, great, app is done. I'm ready. I've tested it. I sent a few prompts and it's good. And then you ship it and you realize that the people who actually use this for their work, they talk to it for 5 minutes and then it starts to take so long to reply, right? That's why context also costs a lot of money, right? But that's why context is always, everything you do with agents, always think about the cost in terms of context, right? So let's move on to streaming. So the key concepts of streaming, like, has anyone used streaming before? Like text streaming in any application? Okay, cool. I see a few nods, right? I think it's funny because like before 2 years ago, no one ever had, right? Like streaming was just not something that anyone ever really had to use, right? But suddenly streaming is important because a model can take a minute to reply and it's going to stream the results down, right? Like I'm sure everyone knows what I'm talking about because if you use ChatGPT, if you say, hello, write me a poem about ducks, it's not just going to think and then give you 2 paragraphs of text, right? That's what streaming is, okay? So the important thing to understand about streaming is that a stream can be initiated on the client or the server, right? And when it's disconnected, it disconnects. When it's interrupted, it disconnects, right? So like, for example, if you're talking to ChatGPT and you reload the page, that stream has been interrupted, right? That's what I mean by when I say when a stream is interrupted, it disconnects. So approaches to streaming, let's look at a few approaches, right? This is one approach, right? So what's going on here? Or maybe, I'll put a question out. Let's think about it, okay? Let's imagine that for this application, you're doing a ChatGPT-like application. Okay, you're just making a nice like message app where you can talk to an agent, right? So here we have the client, the API, the agent, and the database, right? So can someone tell me what happens? What do I see on the user interface in this model when I ask, give me a poem about ducks? Does anyone want to? Like, what will happen? What will the user see? What will the user see while the agent is doing that? Sorry. Yeah, you basically see loading spinner, loading. 1 minute later, poof, right? Awful user experience. I still see a lot of people building apps this way, right? So yeah, that's what will happen, okay? So let's look at the other approach, client only, right? So again, someone want to tell me what happens here? Dow, I'm picking on you. What does the user see when they ask, I want a poem about ducks in this architecture? Yeah. Okay, can anyone tell me a disadvantage of this? Even compared to the previous solution? No, you get the response immediately, right? So it's much better in that sense. But are there any disadvantages to doing this? Sorry, it might get interrupted. Yeah, sorry, what did you say? Yeah, okay. So what happens if I'm halfway through getting my poem about ducks and I reload the page, right? I lose everything, right? I can keep reloading, everything's gone. So yeah, that can be interrupted and you won't finish the data, right? So, and you can imagine like if you're saying, obviously with a message, it's not really a problem, right? But if you might be using your AI to like write me an essay, right? And you don't want the page disconnects and then you lose everything, right? Because maybe that took a minute or 2 or 3, right? So yeah. Oh wait, so before I go on to the next slide, can anyone think of a third way of doing this, which is, I would say, the gold standard approach to streaming? Do they want to guess how you might solve all the problems here with a bit more complexity? Anyone want to guess? Have a think about it for a minute. I'll have some water. Like imagine you want to solve both those problems. What would you do? So you want something which is going to handle interrupts well, but you also can stream to the client at the same time. Okay, I'll show you how you can do that. Can I zoom in on this? Oh, okay, cool. See that well? Yeah. Okay, cool. Maybe that doesn't come out too well on the slides, but yeah. Okay, so in this approach, what we have is, again, we have client, API, agent, server. What we do here is we say, hey, I want my poem about ducks, right? And then what happens is the agent is going to stream to the server, and then the server is going to forward that stream to the client. So that's something you can do with streams. It's called teeing, right? Where you take a stream, you basically fork it, like think of it like a river split into 2 streams, right? And you forward the stream to the client, and at the same time, you save that stream to your database, right? So then the next question is, what do you save to your database? Obviously, you could save chunk by chunk. So when I say chunk by chunk, the stream comes in tokens. If you write your poem about ducks, it will be like, hi, a duck waddled across the pond. Each one of those words would be a token, right? So if you want, you can stream each one of those tokens individually to your database, right? Not a great idea because you're going to be thrashing your database, right? So pick a number, right? You say, okay, let's say every 300 words I save to the database, for example. or every more like every 3,000 characters or something like that, right? And this way, what you do is you basically take the stream, you forward it to the client, you get to your amount 300 words, and you go, okay, save that to database, and then carry on, save that to database, carry on, right? The advantage of this is that if at any point the client disconnects, what the user then sees is they refresh the page and it's still coming in, right? It's not the best user experience because you refresh the page, it doesn't carry on streaming. The stream has been interrupted. The stream's gone now, right? But if you refresh, you see another 300 characters. You refresh again a second later, you get another 300 characters. So it's consistent. It's eventually consistent, right? You're going to get everything you want. So the stream is forwarded from the server to the client. On each completed message part streamed, the message is saved to the database. If the client disconnects, the stream still continues. And then to address the last concern that I had about how it's not the best user experience, you can actually add a fallback. So that, for example, if the stream disconnects, and you can easily have a handler for if the stream disconnects from the client, you can use a WebSocket or something, right? It's pretty confusing, pretty complicated, right? But this is why I say this is the gold standard streaming approach, right? Which is basically like you have a fallback. So rather than streaming token by token, it goes, oh, I lost my stream. Okay, so you can just poll the API. You could poll the database every second because I know I haven't received message complete yet. So until the message is complete, I'm going to keep asking more data, more data, more data. You can use WebSockets. You can use some fallback, which says if the stream gets interrupted, get me the fresh data. Yeah. Any questions? Okay, cool. So actually, I'll do a demo of this quickly. And actually, for this demo, I'm going to demo Gamma itself because I think this is an amazing tool. This is how I made the presentation. So, and this for me is the gold standard in action. So let's say, yeah, cool. I'm going to create a new presentation. I'm going to do, let's see, generate from one line. And you just say ducks, right? I want a presentation about ducks. Generate outline. Okay. Okay. Okay, cool. Looks fine. Yeah. Okay, 10 slides. Nice. Okay, generate this presentation. Okay, so you'll see now they're making this presentation. They're going to stream it to me any second now. Yeah, cool. So yeah, it's streaming in. I rewrote the page and it carries on streaming. That's really nice. That's the aspiration. Obviously, don't start with this, but this is really cool, right? So of course, you can start with whatever approach you need, right? But this is how good it can be. So let's quickly talk about Convex. Has anyone heard of Convex? Wow. Okay, so Convex is a backend as a service. It's not an API layer like normal. It's a sync engine. So it seamlessly handles real-time synchronization between client and server. So with Convex, you get automatic reactive updates without the complexity of managing WebSockets connections manually. So why this is really useful is because in terms of what I was talking about with the complexity of handling WebSockets or whatever, it's a sync engine. What it essentially means is when you save something in the database, it just gets sent to the client. Right? So Convex has become really popular in the last year or so because of everyone building these AI apps, right? Because it makes this streaming problem like really solvable. So in order to demo that, this is using Convex, and let's see, DAO, big in on you, creating a story, surfing in Bali, create. So what this is going to do is because it has this Convex backend, every time the API, every time the server gets a new thing into the database, which is writing the story, is going to add that page, kind of sync down, right? So it just means we should get something coming in a minute. It just means that, okay, so there you go, right? So this isn't really streaming. This is Convex magic, right? This is like on the back end, it created an entry in my database, which is a new page in the book, right? And then it comes down as a new thing. So now it's all streamed in nicely. So yeah, Convex is good because it really takes a lot of that stuff away from you. Obviously, if you work in a client, maybe you can't use Convex, right? You know, you have to create your own WebSocket layer or whatever, or you just don't, and you deal with the complications of not having that, right? Continue, right? So yeah, cool. Oh, that's my presentation on ducks, right? So in summary, in this section on streaming, we've got 3 approaches. We've got server only. So server busted streaming, it ensures integrity. It means that it's only saved once the whole stream comes in. We got client only, which provides the real-time updates. Very simple to do, but it is interruptible, which if you interrupt, you'll lose everything. It disconnects. And then you've got client and server, which is amazing, but very complicated to do well, right? Because if you think about all the things you have to handle with client and server, probably more than twice as complicated, right? Because you have to handle teeing the stream, you have to handle saving it in integrable parts, and you have to if you do it the best way, you also have to have something on the client which handles the disconnect and says, if it disconnects, what do I do now, right? So yeah. So cool. I've just been talking for a while again, almost an hour. So I'm gonna, we're probably, for the next step, I think everyone just play around a bit again. It would be cool if you try and build something with the Mastra project. It would be nice if you want to stick with Agent Kit, you can do that. And yeah, just try and build something cool with one or the other. Some ideas, you could integrate different document sets. So using the embed script that I provided, add your insurance policy, add the Confluence pages from the real conference, because right now it's just mock data, so you can see how good is it actually. You could enhance user interaction, so add more features, so that basically right now when you click, you can get the iCalendar event in my app, right? So if I show it quickly, where is it? Let's use the deployed one. Nope, not there. 2002. Yeah, okay. So right now, if we do like session on making apps, then you'll see that we get the session. We have the save button, but you could add more, even if it's just like save all, or you could add something like, yeah. Oh, another one would be like download from the database where you got this. Oh, sorry, there's this thing. Yeah. You could do something with working memory. So we have session ID already here. A good thing you want to do is if you want to, for example, change it into a travel agent app, you could, for example, like inject a nice thing to do, like give some UI to the user where they can click around, especially if you know React, you can do that quite easily. And then feed that to the backend and get it to change something, right? Add some front end tool calls, whatever. And yeah, let's see what else you could do. This will be very complicated. I don't think anyone is going to manage this, but I didn't show you can actually add MCPs quite easily to Mastra. So an MCP is Model Context Protocol. So you can just add an MCP server to a Mastra agent. So for example, you could add the Google Calendar MCP so that when you click Save Session, it actually saves it to Google Calendar, right? I'll be shocked if anyone can do that in 40 minutes, but you can try. So yeah, you can try streaming. You can have a look at streaming. How can you stream something from the client to the agent? And yeah, you can add more tool calls, like you could add the web search tool or CopilotKit chat with your data, this kind of stuff. So if you want some real inspiration, you can check it. I'd say for this last one here, this is more like if you want to have a look afterwards. I don't think you'll have time to get anything doable there. But yeah, just basically like at the very least, you can edit the system prompt, right? Like take the use case I have from the front end library and like change it from, rather than talking to some document, talking about something else. I think someone over here was asking about how to add another agent, right? So that you can route it. I can come over and help with that too. So yeah, just have a go. Like 40 minutes. I'll obviously go around. I might try and find some people who are quite experts in React development and maybe see if you can help me help other people as well. And if you don't want to do any React development at all, then you can play with Agent Kit. That's obviously completely fine. That's easy to do as well, right? Cool. Any questions or anything about what happened next? All right. Awesome. Thanks, guys. I will float around. Guys, just quickly, because I got a question from over here and it's a good point. If you want to, for example, connect your insurance PDF or whatever, then obviously you'll need to run that embed script, right? You can run it like with the Postgres database. It's just that it will clash with what everyone else is doing, right? But it's kind of fine. I don't expect many of you to be doing it, but just be aware that if you run an embed script, it will replace the actual one. So what you can do then is if you search for index name, yeah, then the index name here is documents, right? So you can just switch this from documents to my documents, or you put your name under it or something, and then it will embed in the database using that table. It will create a different table, right? So if you want to, you can just do that. Just change this index name. So let's see, is it exported properly? Yeah, so this is on the main branch. Yeah, so just replace this index name, because you can see that this index name, this is the name of the table in Postgres, right? So if you just change that to documents / your name, then it will create a different table. You can use it. Or if you want to not use Postgres, then you can switch it to a libsql. And that's in the slides. If you go to the slides and just search for vector store, let's do it quickly. If I search for, yeah, then you can see here, it's on slide, not sure what slide number this is, but just search for vector store. And you'll see that if you want to switch it, you can just do a search for the Postgres vector and replace it with this instead, right? Either is fine. So if you switch the vector store, you have to change it in two places, right? You have to change it in the vector query, right? And then you also have to, so here, PG vector. If you just do a search for PG vector, you'll see where it's used. So you can change the vector store here, and you can change it here as well, right? I'll just demo it quickly, right? If I want to actually do this, then let me do it. So I'll show you the easy way to do it, which is just change the index name. So let me change index name from documents. I'll change it to documents Simon. Okay. And then I will come here, cd into apps, web app, and run yarn embed docs. I think I've gotten the wrong thing. Where is it? Web app. I'm not using yarn. pm embed docs. Right. And now, okay, dash doesn't work, I think. So let's do documents _ Simon. Cool. Create the chunks. You can't log into that database because it's on my account, but just trust it's there. You can use it if you want. Let's check the database tables. So you can see now, yeah, the embeddings are there. So you can't check this database, but it will work. You can just use it. Or the other way of doing this, which I was talking about, is instead of the Postgres store, you switch it out here. Where is it? PG vector. So just do a global search for PG vector. And instead of doing that, just replace it like this. Const vector store equals this. You have to add it. Okay. So yeah, install the package, which is just this Mastra libsql. I've got 16.1, but I guess you can take whatever the latest is. And then switch this out for libsql vector, and you have to provide a file. So like this. So there we go. Switched out there. And then you also have to change it in the other place. So, because remember, you need to change it in the tool call, but also in the embedding. So here, and then if I run embed docs, I will actually get an error, I think, or maybe it'll work. It works. So the script will also actually create this file. So I fixed that one. So basically now when you do the vector.db, you should have here, let me see, where does it create? Files, data. Oh, it's still indexing. But basically it should create a data libsql file. I can't remember where it goes. If it goes, I think it's supposed to go here. But anyway, if you're struggling with the libsql, just use the Postgres one. It's easier. Yeah, like just change the index name. Easiest thing to do. Okay, guys. So yeah, we're basically at the end. I'll just go over some questions which I got from floating around. So I see that some of you made some progress. Like, I hope that I just whetted your appetite for, obviously, if you want to go and do this, give you a starting point. Some problems, some issues I made with the thing is the index name, which you have to switch for embedding and then showing the documents. So I actually realized there's kind of, I mean, it's not really a bug, but it is confusing. I did fix this in my final example, but it's actually specified twice. So if you do want to set this up with other documents, sorry, you have to change it in 2 places, right? So, or what I did in the final solution is I made it into one exportable config, which is what it should be, right? So if you do want to put your name there, like documents _ DAO, you have to change it for the vector search tool and for the embedding tool, okay? But I did see going around, some people were able to add Apple Care document, other stuff there, and it actually was searching. Cool. Also, if you're extending this, bear in mind that if you just change the document, it is still going to try and mangle that response into the format of sessions. So we had an interesting example here where we added the Apple Care document and then said, can I replace the phone if the phone's scratched? And then it said, your session on can I replace the phone if it's scratched starts at 3 p.m., right? Because obviously it's still trying to do what you told it for. So you'd have to change the prompts, change the agents, etc. If you're interested in, so you'll notice that the actual deployed application, which is the one that I shared in the Confluence document, like before, the one which actually works for searching sessions, is much better than the one that I built in this, because I did my own example of, I'd spent an hour doing this myself and I made the Session Explorer improved. So if you want to have a look on that branch, you can see that it's better, why it's better. The reason why it's better is because I actually feed the agent, here is the list of sessions, you have to pick one of these, and not always try and get it to recreate a session based on the search results. So obviously that's going to create better results because it's going to give you that just deterministic response, and it's also going to be faster because you're not always asking it to regenerate on the fly. So if you're interested, have a look at that branch. There's also a few other fixes on there. That was my final demo. So yeah, which I don't have time to show now, but it's also deployed, so you can just go and have a look at it on deployed on Amazon. There's a link in the slides. So yeah, and then one more thing I wanted to mention. Oh yeah, the Mastra dev server is a really good way of debugging stuff. So what that means is, like, let me actually open this up here on localhost 4111. So you see that if you run this, so by the way, if you just cd into web app and run pm Mastra dev, you can see it in the package log. Then you get this dev server, which I already did demo very quickly earlier. But the nice thing about this is you can talk to all your agents and test them out, right? So earlier, let me see, I'm running the wrong server here. So let me see, go to here, shut this down, and instead go to my demo, split the terminal, and we'll go cd, come on, cd apps, Oh, I'm already here, right? So it's PM Mastra dev. Oh, Mastra dash dev. Yeah. Okay, cool. So that's going to start up. And what is nice about this is it's a nice thing where you can debug stuff. Okay, so it's running on port 4002. So now if I go to my agents and I go to the Camp Assistant agent, you can just chat with it like normal. And you'll say like session on making apps. And this is another question I got, which was, can I actually stream the tool calls? So you'll see here that, yeah, right, it's actually streaming the result from the tool call. So this is the session format agent, actually. Sorry, I don't know your name, Seb. So this is Seb's question. Can I stream the tool call, right? Which looks really great. And yes, you can. Mastra supports it, but CopilotKit doesn't support it. So that's always a concern you have to have. That doesn't mean that Copilot is rubbish. It doesn't mean that you shouldn't use it. You can implement this yourself, or you can wait for Copilot to support it because they will. It's in their pipeline, right? Or you can also look, if you look on the Mastra documentation, Mastra docs, let's say like front end. Let's see if they say, if I can just find it like that. Somewhere in here in the docs, you can see all the different, let's see if I can find like CopilotKit, CopilotKit. Yeah, frameworks, Agentic UI frameworks. So you can try with Vercel AI SDK, you can try with other ones. Maybe one of these front-end libraries does support streaming tool calls, right? So you can have a look at these docs, try those. I only tried CopilotKit, it's the only one I want to try with. I ran into some limitations. I might try one of these next, yeah, because there are some other limitations as well. Cool, so yeah, that's kind of all the feedback I got from, oh yeah, and then one more thing to mention with this. This is actually quite complicated. This is called a nested stream. Because if you actually think about what's happening here, you have one agent calling a tool call, and the tool call is then calling another agent, and that agent is streaming to the first agent, and that first agent and then streaming to the user. So if you want to get that set up properly, you do actually have to do it in the way that it's done here in the session format agent. So if we go here to agents in my app, yeah, agents here, and we look at the tool call, which is search sessions tool, and open this up, come on. Then we can see here, session format agent is used by the vector query. So the reason why this works is because we have this. That's how you need to do it that way, right? So this is all in the Mastra docs, but if you didn't do this, if you just kind of like wait for the answer and then pass it back, obviously it's not going to work because that's just the first agent doing like a normal async request, and after a minute it'll get a response, right? So this is the magic here. We're actually receiving the stream from the parent and then piping the second stream into the first one. So if you do want to do this like nested tool call streaming, it's called, or nested streaming, you need this. And I would love to have an example to show you now where I did use like maybe Vercel SDK or some other UI library, and I could show you, because we know it's possible, right? Because I don't know what library Mastra is using, but they're doing it. They're streaming the tool call here, right? So it's definitely doable. Cool. So yeah, that's the feedback from that. So let's go to the summary, basically. Come on. Yeah, also, I hope you guys, I kind of skipped over this slide, but if you do want to vibe code more with this setup, definitely use these MCPs because they're the doc service for each of the tools we're using. So the demo which I showed you, the final one that works, I vibe coded it 100% in 1 hour. I didn't write a single line of code. I just added these MCPs to Claude, and I said, it needs to be better. What I actually did as well, you'll see on there, it works really well. Write tests. When the user asks for a session on Python, this is what it should return. And then Claude Code wrote me a test to verify that. And then I just tell Claude Code, keep improving it until you get the right answer, right? So that's a great way of vibe coding with this setup, right? And if you just add these MCPs, it all works very nicely. So if you check out my final demo branch, which is the third branch on the thing, you can see how those tests work and stuff as well. And you can add these MCPs and you can go ahead, and it will be much, if you want to spend an hour doing the Apple support docs thing, that would be the best place to start. Just like add the MC and just let it run and it will do a great job. And that's exactly what I did. So yeah, the video is there if you want to watch it. Yeah. So let's skip down to the end session. Streaming, we already covered. Yeah. So there's one more concept here as well, because I kind of skipped over it earlier, which is advanced agent concepts. So I'm just going to blitz through this in a minute because I have the slides. Yeah. So this is really like an advanced concept, which is why I saved it right to the end. And if you're interested in this, you can have a bit more of a look later. But earlier, I kind of skipped over the idea of this fire safety agent, right? The agent which is going to take just the door examples, like take from the massive architectural diagram, just the stuff on doors, and then how it's going to work, how it's actually going to apply its edits. And so this is, you won't find documentation online about this. This is my acronym for how I think about this, right? But basically what you want to do is you want to filter, abstract, reapply. So what I mean by that is, let's take, we have the whole 1 GB file of building architecture application, right? What you want to do is use a deterministic filter, that could be SQL, it could be anything, to slice out the context that you want. Do not use RAG because you need it to be very structured and formatted, right? So think of it like a Git branching, right? But you're only branching the bit you need. You pass that to the agent, and then you say to the agent, like, make this more safe, make it regulation, right? And then have the agent update that slice of context, right? And then reapply that back into the main context, right? So this is a good way of how you can, if you have something really complicated that you want to do, obviously you don't want to give the whole 1 GB file, you want to slice it out. But the point I'm making is slice it out deterministically, because if you slice it out deterministically and then have the agent work on it, you can then patch that back into the whole thing again, right? So that's a much better way of thinking about how to do this, right? So yeah. So we see the idea here is basically you take the filter, you abstract out, the agent summarizes what it finds, and then it reapplies those edits back in. But just a note on this, you don't have to do all this. This is basically implementing your own reasoning, if you think about it. That's what you're doing, right? But you don't have to implement the reasoning yourself. You can essentially have a tool call, which is going to do that, right? A tool call to filter out the context, abstract over it, and then merge it back in again. You don't necessarily have to very hardly program in, like when the user wants to do fire safety, then filter out like this, whatever. Basically, if you structure your tool calls in a way that does this correctly, maybe you can just shove it to Claude Code, ChatGPT, whatever, and it will just run. Yeah. Okay. So yeah. Why far matters. It's deterministic, it's stable, it's efficient, it's auditable. Auditable is a big point as well, right? So the fact that you can basically take the slice of state you need and then slice it back in again. Cool. So yeah, I'll skip over this slide. But yeah, that's when to use it, right? When you want to modify a complex structure of data, when you want to keep your reasoning actionable, and when you want to validate and improve your changes step by step. So yeah, the key takeaways from this whole massive workshop we've just done. Understand the core concepts. So I hope that everyone at least has an understanding, like we have model, we have system prompt, we have tools, how that kind of stuff works. Architect, don't monolith. So just like before in building normal applications, you don't need to make some God system which does everything, right? You can split out the bits you need, separation of concerns. That doesn't mean that you should start with the most complicated version of everything, right? Everything I showed you, it was the ending point that looks nice. Of course, I started with a monolith agent, right? Because you just see how good can it be, right? I shove all the context, just do the thing, right? But then you very quickly find like, oh, it's more efficient if I just carve out this slice, give it to the specialized agent, save on reasoning power, make it faster. So of course, by all means, start using the trivial make one agent do everything approach. But if you can then separate it out, if you know these tools, then you know the tools that exist. That's how you can optimize and improve. So yeah, use the right tools. Check out Mastra and CopilotKit. There's a bunch of others. They're changing all the time. The point of this was not to become an expert in those tools. It was to show you what you can do with them. And then I'm sure new concepts are evolving all the time. Master streaming is good to at least know what good looks like. Even ChatGPT, when they first started out with streaming, you reload, you get disconnected. It took them like 6 months to fix that when you reload, the stream continues, right? So obviously everyone is learning this at the same time, even OpenAI, but like knowing what good looks like is really helpful there. Apply the FAR pattern if you're getting really advanced. And yeah, just have the core mindset, build smarter, not harder, and let agents handle the heavy lifting.